Come to the post-contest discussion of Leetcode Euclid 362. I'll start with the question number 1. The question number 1 is about the point that intersects with cars. There are an array given of nums that contains the start time and end times of every car, and just have to output the how many integer points that are covered by any part of a car. Okay, the integer points can be from 1 to 100. Let us consider this as a number line, like if this point is 1, this point is 2, this point is 3, this point is 4, and the 100 till 100. If a car covers points from 1 to 3, it will be like this. It covers from 1 to 3, and if a car covers point 5 to 5 only, it will cover this point. Okay, the number of points that are like for the answer, the number of points covered by any part of car will be 1, 2, 3. It is 3, and this 5, that is 4. And if another car covers from 2 to 4, then all of these 5 points will be covered. Then the answer will be 5. So we just have to output how many points are visited by cars. Okay. For that, what we can do is the numbers are from 1 to 100 only. We can make a factor that represents the number line. For every index of the factor represents the number line, and iterate from the start point of each car to the end point of each car, and mark all the points as 1. Like you can see if here exists a car, I can mark this point as 1, 1, 1, this point as 0 because this is not visited by any car, and this point as 1 because this is visited by a car. Okay, now if I add these numbers, the answer will be 4. Okay, that is what I have done in the first answer. I'm just iterating through the vector, and I'm iterating from the start time of its car to the end time of its car, and marking its index in the number line as 1, if that is because all these points will be visited by car. So I'm marking this as 1, and after that I've just added the answer. That will be the answer. This is an easy question. Let's move on to the second question. Okay, we are given 4 integers as x, like start points of a grid and end points of finish points of a grid. Just have the output if you can reach from the start to the finish after exactly 3 seconds. Okay. The first thing to notice in this question is that if I can reach this finish line in the minimum number of time, like if it is like what will be the minimum number of time I can reach from start to finish. Okay, and there is also another thing given is I can move in any 8 directions, in any 8 cells around it. Let's see in grid. Like if you notice this grid, uh, if I start from this start point, let me download this pixel. Okay, cannot download this pixel. This is not possible. Oh, sorry. Not possible. Okay. Let's see. If I start from this start to this finish, what will be the minimum moves in which I can go from start to finish? That will be like if I move from the corner side. Okay, if I move from this start to this, just the corner part of this, and this and this, and again I will go to this by like in row. Like this will be 1 step, 2 step, 3 step, 4 step, 5 step. In 5 step I can reach from start to finish by because I'll just I want to go with in the minimum number of steps to the finish. I'll go till like in corner positions to the finish. Okay. Now next, what I can do is if I reach finish at the minimum number of times and t is bigger than the minimum length, then what I can do is I can reach I can before reaching the finish, I can move to the least position and toggle between to the corner position and then go below, go up, go below. Then when there is like in exactly 3 seconds, I can just move from any of these cells to finish. And so you can see that if I can reach finish at t time, like if I can reach finish at t time, then I can reach the t time, then I can reach the finish in any time greater than t, like because I can just I'll just keep toggling between the corner position and its side position, and I'll reach finish after at the gate time that given t time, like if I reach finish at minimum number of times like mn, denoting that as mn, then I can reach the at any amount of time like t can be greater than mn, because I'll just keep toggling between any of these positions. Then I'll go to finish at exactly t second. Okay, now just I have to just output the I'll find out the minimum number of steps to go from start to finish. How will you find that out that? Okay, you can see that I can go from x. Let us consider I am going from xy to ab. At each step, I can decrease x if ab is less than x. I can change x by 1 and y by 1, or otherwise I can change x by 1 or y by x by, let us consider plus minus 1, something plus minus 1, and y by plus minus 1. And another thing we can do, we can change x by plus minus 1 or y by nothing, and or otherwise we can change, we do any operations to x and change y. We can do this this around 8 operations. Okay, these 8 operations. So what happens? The minimum number of steps will be given by this only, because I am decreasing both x and y at like uh, both x and y. Hmm. So it is doing twice of this. I'll take 2 moves from these 2 like processes, but it will take 1 move only. So if I move corner wise, the answer will be, the number of steps will be minimum. So what we can do, we'll just go to the corner wise until the one of the indexes, like one of the rows or columns is equal to finish. Okay. So the minimum number of steps will be only the difference between the in the row or the column of the start and finish. That is that is x minus y, or sorry, x minus a or y minus b. Maximum of this, because we can decrease or increase this sense x to become a, or sense y to become b at like any number of times, but there will be left out of these 2 things, because if I move from this start to this finish, you can see that I can cover this square in these 3 steps only, but I have to go extra 2 steps in the column wise. So that is the answer. The number of number of minimum steps will be the maximum of absolute of like difference between the x coordinates and the difference between the y coordinates. Okay, that is the minimum, or the minimum part. If t is greater than equal to minimum, like t is greater than equal to minimum, I will just toggle between the adjacent position and finish at t time. So for every t that is greater than this value is possible. That is I have to return one. But there is an edge case of if the positions are equal, like if both points are start and finish points are equal, I can take 0 moves. I can take 2 moves also, because I can move from this start to let's consider start and finish are both are this in this grid only, this cell only. What I can do, I can move from start to finish in 0 moves, and also I can move from start to finish in any number of moves except one, because if I in one operation I can go from this to D here, but I can return here. But otherwise I can just go from here to then return here in 2 operations. In 3 operations I can just go to where, go to here, then return here. In 4 operations I can move a full circle. So, but for one operation, I'll just go to here, but I cannot return from this position to this. So the if the given t equal to 1, if t equal to 1 and the both the start and finish are equal, that is the minimum path is between them is 0, then we have to return false for t equal to 1. Okay. That is the solution for B. The solution is easy. We have to think clearly. Okay, the next question. We have to calculate the minimum number of moves required to like make all the grid 1 1 1. Here you can see that in the example, there is a 2 in the 3 comma 2 position. This position, I have to make this 2 as 1 and make this 0 as 1 also, because the 0 I have to make the whole grid 1 1 1. Okay. The sum of the values in the grid will be 9, so it is always possible. You can see here now the grid is equal to 9, so it is always possible. There will be no zeros left out after all the operations. We have to find out the minimum number of moves required to place one stone in its making the grid 1 1 1. Okay. Now, so how do we derive the answer from this question? The first thing to notice is that the grid size is only 9. We can do any brute force, n factorial, that is 9 factorial is 362,280, 362,880, 362,880. But 362,880 is not a large number. It's around 10 to the power 6. If it is, but we can do 10 to the power 6 operations in 1 second. Okay, so we can go for an n factorial solution also. So how do you get a solution? So the simplest way to is to, like, if I have the grid, I just change this to 1. Like I'll just move this 1 from here to here. For this question, I'll just move 1 from here to here, or here to here, here to here, here to here. Like I'll try out every possibilities, like to like move three make this like balanced. Like I'll move 2 from here, like 1 here, 1 here, 1 here, 1 here. This is 4 positions. So I'll try out every possibility of moving 1 from any other indexes. So that is what I am doing in the solution also. You can see it is but a very good looking solution. Okay. If I'm iterating to the whole grid, if I have any cell that is greater than 1, that means I have to move from that cell. I'm marking that I'm marking my indexes as by that grid cell. Okay, and I'm subtracting 1 from, because I will be moving from that cell to another cell. Okay, that is this break condition is to just break from the root. Because if there is no indexes that is greater than 1, that means the grid is already solved, balanced. That means the answer is 0, because grid is already solved. Now, if another after subtracting 1 from this, I will be moving to another like cell. So if another cell is 0, I'll just try to move to that cell. After moving to that cell, the cell will become 1, and I'm calculating the number of steps will be this, because x in distance equal to, because that this will be the Hamiltonian distance between this two, coordinates. That is the minimum distance required to move from that move from that coordinate to move from this coordinate to this coordinate. Move from this coordinate to this coordinate, the distance will be I minus this minus this, x coordinate of this minus this plus y coordinate of this minus this. Okay. Then after making this index as 1, that is I move to this index, and then I am doing like finding out the minimum answer from the new form grid. To this is a brute force solution only. I'm moving from every possibility I'm trying out moving from every coordinate to every other coordinate that contains a 0. And that is the whole solution only. I have now solved the. I guess I can end here today.